Okay, hi guys. So we'll be continuing on more on stopping potential. So, and then last lecture we discussed the stopping potential with the following equation. That the stopping potential V naught would be H upon E nu minus H upon E nu naught. Okay, so on the sim we will be seeing a graph. So we have this graph. Okay, so this is the stopping potential V naught, and this is the frequency. So let me write down nu naught only. So let's suppose for nu, so this is nu naught. So for nu equals to nu naught, v0 would be 0. Okay, and for nu equals to 0, v naught would be h by e nu naught. Okay, so obviously it would be a negative quantity, and afterwards we will have a slope as h by e. Okay, so some conditions here, that if lambda is greater than lambda naught, lambda of photon is greater than lambda naught, there won't be any photocurrent. Okay, so I hope you understand the relation between nu and lambda, that lambda is inversely proportional to frequency. Hence, for frequency of photon more than nu naught, then there would be a photocurrent. Okay, but when the lambda of photon would be greater than lambda naught, then there will be no photocurrent. Okay, when lambda photon is lesser than lambda naught, then there would be a photocurrent. Okay, so value of stopping potential is dependent upon the frequency of photon and the binding energy of metal. Okay, so value of stopping potential, which is V naught, is dependent on frequency of photon and phi naught, or rather this is the binding energy of metal. How? Obviously there is a term nu here and nu naught here. Nu naught refers to the binding energy of the, so this term actually refers to the binding energy of the metal. Okay, and stopping potential is independent of the intensity of light. Okay, so this is constant nu. At constant nu, V naught is independent of the intensity of light. Okay, why? Because the intensity of light is only cared about extracting or ejecting more number of electrons from the cathode or the negative electrode, but the stopping potential is dependent upon the kinetic energy of the electrons which are ejecting from the cathode or negatively charged plate. Okay, hence as the kinetic energy is not dependent on the intensity of light, V naught would also not be dependent on the intensity of light. Okay, and phi, which we defined here, the binding energy, is dependent on the surface of metal. different surfaces would have different binding energies. Okay, so just to draw a graph between intensity of light and kinetic energy of photons, you would have kinetic energy of photons is independent on the intensity of light. Okay, now let's discuss some of the questions wherein you have to calculate the kinetic energy of a photoelectron, kinetic energy of photoelectron in electron volts emitted by a sodium metal when light of wavelength equals to 400 nanometer strikes on it. Okay, so the binding energy of sodium metal is 2.3 electron volt. So you calculate the stopping potential. Also calculate stopping potential. Okay, hence first let's start that E equals to h nu. Okay, so we have been given that the so before actually calculating that, so first you have equals to h nu. This is one of the ways of having the energy. Then another way of having the energy in electron volt is 1240 upon lambda in nanometer. So this is very important, just remember this. I wanted to tell you this in the same question, that if you want, oh sorry, this is in not nanometer, rather the wavelength lambda is in nanometer. Okay, so it is in nanometer and this is in electron volt. This energy was in joules, and if you have to calculate energy in electron volt, you have to use this formula. Okay, so you have been given the wavelength of the incident photons as 400 nanometer, so this would be energy of 3.1 electron volt, and stopping potential would be nothing but, or rather first let us find the kinetic energy. So the kinetic energy would be again the energy coming minus threshold energy, which is 5W, or the binding energy. So binding energy for in case of sodium metal is 2.3 electron volt and energy of the photons is 3.1 electron volt. Hence kinetic energy of the ejected electrons or photoelectrons would be 0.8 electron volt, and hence the stopping potential would be the same. The same potential has to be applied in opposite direction to stop the photons being ejected from the sodium metal surface. So answer would be this. Okay, so with this we come to an end of this lecture. In the next lecture we will be seeing some more examples of the same, and then we will be talking about some other interesting concepts like Bohr's atomic model and the likes. So till then, good luck and goodbye.